In our last video, we talked about adding a TVS diode onto the TRIAC on LIBCM so that it will fire when a tree falls in the woods and causes a very high voltage. It will basically fire this TRIAC, which will fire the external TRIAC, which will prevent a high voltage from developing across them over the 800 volts that it's rated for. And so I've got that set up now, and I'm going to pop this light on here real quick. And what we have is that TVS is installed right here, and it basically will do exactly what I just said. I have here right now, we're just on auto so that we can see when we're in a safe area, which is 300 volts. So I'm going to apply 300 volts to this guy right now, and you will see that we develop our 300 volts here. And then you can see the 300 volts is here. Because the TRIAC is not firing, we don't actually want it on right now. And then what we're going to do is we're going to introduce a high voltage transient here. Let me pop this trigger up just a bit, and we're going to say single trigger wait. And so now what I'm going to do is I'm going to add another 300 volts externally here, and I'm getting away because I don't want to be near this circuit for obvious reasons, because this is going to be 600 volts. 600 volts is when it starts to get scary. So what we're going to do is we're going to pop this on. You're going to see that avalanche down, and because I have a current latching circuit on there, you saw that voltage tank, and didn't trigger. So let's see what happened. I imagine that with our time scale this was just too long, so let's zoom in a bit. We'll go here to 2 milliseconds, triggering channel 1 rising edge. Okay, and then we need this to be, and that should have triggered. Let's try again here. So we'll single trigger this, hit our 300 volts here, so you can see our 300 volts develop, and then you'll see this guy, there we go. Cool. I think that the time base, the trigger noise filter was kicking in there. So let's see what we saw. Wow, that kicked in real quick. Yeah, so I do need more time base here. Let's see if we can get one more trigger here a little better. So, there we go. Doing this safely on camera is always fun. Okay, so we have our 300 volts, and there is that. Okay. So the reason this is ramping so slowly is actually my external supply has a very soft ramp rate, but this is fine. So you can see that you can see where we actually collapsed. So we did actually capture it here. So if we zoom in, you can see that we got up to about, here's where our avalanche diode kicked in, and that was at about 450 volts or so. So that worked pretty well. Let's zoom in, and let's actually find that falling edge. So we're going to change our trigger to be a falling edge trigger, and I hope it doesn't delete my data when this happens. Good. Okay, so nope, I didn't change it. Let's try that. There we go. And then we're going to do that, and we're going to pop our trigger right there, and we'll try this one more time. Hit the camera. All right. So there is our our expected voltage. There is our drop. So yeah, now we can really zoom in on this signal here. Let's see what we got. 2 milliseconds. That'll probably be decent. Yeah, now I'm going to do it one more time here, and we've got a much tighter base here. You can see how quickly that diode is kicking in once we exceed the voltage. It's just a few hundred nanoseconds, which was the TVS diode we would expect. Okay, we're going to hit it again. There we go. Yeah, so we were actually pretty close there. So this scope doesn't have the bandwidth to even really measure this. This is a 100 megahertz scope, and right now our time base here, if we put our cursors on, manual, oops. Manual cursors here, and then we're going to get cursor A from 90% to say 10. No, actually, no, we do have the bandwidth for this. Yeah, so this event was about 4 nanoseconds long, which our 1 over dx is about 15 megahertz. So anyway, yeah, it's very, very quick. So we should be able to stop pretty much any transient. And the way that we stop it is we fire the TRIAC, which means that, of course, briefly the grid charger is going to turn on. This is the 1500 watt grid charger will turn on for one power line cycle until, you know, until we have the next zero crossing, or really for half of a power line cycle until our next zero crossing. Anyway, this works really, really well, and it's a very simple mod. Let me turn off these high voltage supplies so that I can touch these, and then unplug that. It'll also probably be a little quieter. Okay, so yeah. All right, we've gotten rid of our high voltage at this point. So all this mod is here is I'm literally soldering this TVS diode to pin 4 of this isolation bridge, and then I'm soldering it to the back side of the TRIAC there, which is pin 2. So it's an easy enough mod. And so this will be on all of the 1500 watt grid chargers for the 1500 watt FOMOCO setups. Again, if you're just using this built-in TRIAC, it has a snubber already that's eating the transient event. So the existing, I know I talked about this before, but this snubber right here, the C33R73, is able to basically eat this pulse here. Now the TVS diode will make this more resilient to overvoltage. So again, I'll add it to the Rev E PCB, but for the Rev Ds that are going to go out, it's just going to have this guy soldered there. Totally fine. No issues there. It's going to be easy to solder. Yep. As always, thanks for watching.